Part I, differentiate y equals 5x squared ln 3x. So first thing to notice is this is a product of two functions. We've got the 5x squared and we've got the ln 3x. Therefore, we're going to use the product rule for this. So I'm going to let u equal 5x squared and I'm going to let v equals ln 3x. So differentiating the 5x squared gives me 10x. Then differentiating the ln, well, I know that ln will differentiate to be 1 over, so I get 1 over 3x. But by the chain rule, because of this 3 on the inside there, I need to multiply by the derivative of 3x, which is 3. And then I can see that those 3's cancel out, and actually just gives me 1 over x. So now applying the product rule, which remember is u dash v plus v dash u, I get 10x times ln 3x plus 5x squared times 1 over x, which will simplify and give me as my final answer for part I 10x ln 3x plus 5x. So that's my answer for part I. I could leave my answer like that, or I could do a little bit more simplification here by factorising out the 5x, because 5x goes into each of these terms. So I could leave my answer like that, which is a little bit neater. Right, let's move to part I. Excuse me. So, given that y equals x over sine x plus cos x, I need to show that dy by dx is equal to all of that. So I've got a fraction here. I've got the x on the numerator and I've got the sine x plus cos x on the denominator. So I'm going to use the quotient rule to differentiate this. So I'll let u equal x and I'll let v equal sine x plus cos x. So differentiating the x, I get 1. Now differentiating sine x, I get cos x, and differentiating cos x, I get minus sine x. Now to apply the quotient rule, which you do get given in the formula booklet. Not quite in this form, but you do get given this. Looks slightly different, but it's the same thing. U dash v minus v dash u over v squared. So in this case, I've got the u dash, which is 1, times the sine x plus cos x, minus the v dash, which is the cos x minus sine x, multiplied by u, which is x. And that's all divided by v squared, which is sine x plus cos x, all squared. Now to just expand those brackets. So on the numerator, I've got the 1 times sine x, which is sine x, the 1 times cos x, which is cos x. I've then got the minus cos x times x, which is this, and then I've got the minus times the, actually let me just highlight this to make it super clear. I've got the minus times the minus sine x, which is a plus sine x, times by the x, so we get a plus x sine x. Expanding the brackets on the denominator, I get sine squared plus 2 sine x cos x plus cos squared. Now, at this stage, we can simplify this quite a lot because on our denominator, we've got a sine squared plus cos squared, which I know is just 1. And I've got a 2 sine x cos x, which I know is just sine 2x. So this, my denominator is going to simplify to be 1 plus sine 2x. Then on the numerator, let's collect up the like terms on the numerator. I've got a sine x here and an x sine x there. So factorising sine x outside of those will leave me with a 1 plus x. So just to be super clear, I've got the sine x times 1, which is the sine x. And then I've got the sine x times x, which is the x sine x. Now to look at the cos terms. I've got a cos x here and a minus cos x there. So again, if I factorise out the cos there, I'm going to get a cos x, and then I've got the 1 minus x. The cos x times the 1 is the cos x, and the cos x times the minus x is the minus x cos x. So that is it in its simplest form, I think, and you can see that that does match up with what we were asked to show.